So click the Calculus button, go to Evaluating Limits Analytically, and we are in this section right here. I already talked about that in another video. And actually that 12-1 there, you need to know that because we're going to be using that to solve this problem here. We got the limit as x approaches 0 of x over sine x, which looks like it's turned upside down compared to 12-1. And we'll talk about that here in just a second. As we head over to the whiteboard, so everybody gather around. Let's do it. So we have the limit as x approaches 0 of x over sine x. Now there was something that we need to remember, that the limit as x approaches 0 of sine x over x is equal to 1. So we need to keep that in mind, okay? And at 12-1, we talk about that, and of course we kind of show this numerically, that is, in finding limits numerically, or the numerical approach, or I think the section just before this. Alright, so this is going to be really important. Just remember this, alright? Now, we're going to use this in order to find out what the heck this is, because we don't know what this is. But this is what we're going to do, and the limits have lots of properties that that you kind of need to know. So what I'm going to do here is I'm going to take this limit, whatever this would be, and multiply it by, and you're probably going, what the heck? Okay, just hang in there. Okay, what is this equal to? Well, this is just equal to 1, and 1 times whatever this thing is just whatever this thing is, right? So you're like, well, what did we do? Well, I'm going to show you. Now, the properties of limits is we can actually do this. We can take the limit as x approaches 0 and join these together. And then vice versa, we could go backwards. So we have sine x over x. Yes, this is equal to, well, I put an equal sign there. Erase that. Alright, so this right here is equal to all this. So you can do this, okay? It's a property of the limits. And, well, what can we do now? Well, this is kind of interesting because we have an x in the numerator and an x in the denominator, and they cancel out. Sine x down here, sine x up there, they cancel out. So guess what? This limit, as x approaches 0, right? So all that just becomes 1, and the limit of a constant is just the constant. So there you go, right? Pretty simple. We covered a little property there, here and there. Okay, so just like the limit of sine x over x is equal to 1 as x approaches 0, kind of said that backwards, but so as you just flip it and it's still equal to 1. So there, so go figure, right? And click on the answer there. I'm not sure exactly what I programmed into the help. Oh, okay, there it is. So I don't go through all the steps, but I try to get you started anyway, right? Go back to work this stuff. Okay, so there it is, and don't forget. All right, see you there. Bye.